Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we'll look at partial fraction decomposition with linear factors. So, what is partial fraction decomposition? Basically, it breaks down a fraction with a common denominator into the sum or difference of more than one fraction. So, it is going backwards from finding a common denominator. In this lecture, our focus is going to be on linear factors in that denominator. So when you have linear factors in your denominator, then you're going to have general constants A, B, C, and if you need more, just keep on down the alphabet. Those will go in the numerator over our linear factors. And the goal is to find those general constants A, B, C, and so on. All right, let's look at an example. We have 9x plus 21 divided by x squared plus 2x minus 15. The first thing we need to note is that this must be a simplified rational expression. So if anything can cancel, you would have already canceled it out. So let's factor our denominator. We have x minus 3 times x plus 5. Notice that we have two distinct linear factors. So we're going to put x minus 3 in the denominator and x plus 5 in a separate denominator. And remember on the previous slide we said we have a general constant would go in the numerator, so we'll have a in the first one and b in the second one. So now let's multiply each term by the least common multiple of our denominators, which is x minus 3 times x plus 5. When we do that, the entire denominator cancels out of our first term, so we're left with 9x plus 21. When we look at a divided by x minus 3 and we multiply by that least common multiple, the x minus 3's would cancel and we're left with a times x plus 5. If we look at b divided by x plus 5 and we multiply by that least common multiple, the x plus 5's will cancel and we're left with b times x minus 3. Now, let's collect like terms on that right-hand side. If we distribute, we get ax plus 5a plus bx minus 3b. So I have ax plus bx, which is a plus bx. Then I have a constant of 5a minus 3b. So now I'm going to go through the process of equating coefficients. 9 is the coefficient of x here, and a plus b is the coefficient of x there. So I have a plus b equals 9. 5a minus 3b is our constant, and our constant term over here is 21. And we need to solve this system. Now you can go back and look at prior lectures on solving by substitution or by elimination. I'm going to use elimination here. I'm going to eliminate the b, so I'm going to multiply that a plus b equals 9 by 3. And I'll get 3a plus 3b equals 27. And I'm just going to copy my 5a minus 3b equals 21. When I add, I get 8a equals 48. And when I divide both sides by 8, I have a equals 6. So now I need to find b. And I'm going to go back here. A plus b is 9, means b is 9 minus a, which is 6. So b is 3. So my partial fraction decomposition is 6 over x minus 3 plus 3 over x plus 5. In this case, we have repeated linear factors. We have x divided by x plus 1, that whole quantity squared. In this case, this is linear because of the x plus 1. It's repeated because of that power of 2. So what we're going to have to do is we're going to have to start with the first power of x plus 1, and then we're going to have to go and write another fraction with a denominator of x plus 1 squared. So what this means is that you have to account for all powers. So if this had been x plus 1 quantity to the 4th power, we would have had 4 different terms here. We would have had a denominator with x plus 1, another denominator with x plus 1 squared, another denominator with x plus 1 cubed, and another denominator with x plus 1 to the 4th. So you have to start at the first power and go all the way to whatever the power in the original equation is. So since these are linear factors, we have constants a and b. So let's multiply every term by our x plus 1 squared. So when we do that, we're left with x equals a. Now we have x plus 1 squared divided by x plus 1 leaves just x plus 1. And with b, the x plus 1 squared would cancel, so you're just left with b. So we have x equals ax plus a plus b. So a plus b is our constant. And we have ax, so let's equate coefficients. Here, this is like a 1 in front of this x, so we have a is 1. We do not have a constant term here, so a plus b will be 0, which means b would be negative a, so b is negative 1. So our partial fraction decomposition becomes 1 over x plus 1 minus 1 over x plus 1 squared. So remember that Dr. LB is always in. Please come back for more math help.